Assalamualaikum warahmatullahi wabarakatuh. We want to present our mini group project about zoo dataset. So this is the team members of our group. So for the first team member, it was me. My name is Nar Afifah binti Ibrahim. The second team member is Nurul Nabila Natasha binti Anwar. Third team member is Putri Izzah binti Azizul Hasan. And last but not least, our team member is Wan Mariam Nadira binti Wan Muhammad Zukri.
Artificial neural networks are a form of machine learning algorithm that is designed to mimic the structure and function of the human brain. They are useful for a broad range of applications such as image classification, natural language processing, and time series prediction. For this project, we identify and categorize zoo animal datasets based on the attributes using A and N. Once the ANN is trained, it can be used to classify the types of animals based on the information it has learned. For optimizer were used to change the weights of the network during training to minimize the loss function, which is ADAM, ADAMAX, FTRL, and ADAGRAD. So as we know, many animals have become endangered because of the increasing number of illegal huntings. And other than that, zookeepers tend to make mistakes when handling data regarding many types of animals, especially if the zoo workers didn't have enough experience or knowledge about animals. And last but not least, we tend to have misinformation about animals. For example, based on the knowledge we learn since young, a dolphin is a fish, but to be exact, a dolphin is a mammal. So these are the objectives of our project. First is to predict the animal classification based on zoo dataset variables. Second, to improve zoo technology in handling many types of animal. And the third is to analyze the information of the animal to classify based on the animal's type of species. So these are the scope for our project. First, we import zoo animal dataset from Kato website. Then the dataset consists of 7 types of animal species including mammal, bird, reptile, fish, amphibian, bug, and invertebrate. After that, we test and train the files. So let's get into the data analysis. The data that we use for this group project is zoo dataset. This data will be analyzed with a few series of training and testing to classify the animals with their types. This dataset consists of 101 animals from a zoo, and there are 16 variables with various traits to describe the animals. These variables are received as input as Boolean. So this is the attribute and its explanation. We have 3 attributes here, which is animal name, where it used to describe and identify the animals. And the second one is type, where it is divided into 7, which is mammal, bird, reptile, fish, amphibian, bugs, and invertebrate. And the third one is real value features, where it has features of the animals such as hair, feathers, eggs, milk, airborne, aquatic, predator, and many more, as you can see in the slide. So for the ANN architecture, there are 4 architectures diagram for our experiments. We use input and output layers that has the same value for every architectures. However, we only change the hidden layers for each architectures. Other than that, we use different activation function, which is ReLU, sigmoid, and ELU. So this is the first layer that we use, which has a total of 10 hidden layers, and as you can see, the input layer has 16 neurons and the output layers has 8 neurons. Next one is 20 layers, where the input layers also have 16 neurons, output layers has 8 neurons, and the hidden layers have 20 neurons. The third one, we use 30 layers. where the hidden layers has 30 neurons and the input and output layers have the same neurons as before. The last one we use is 40 layers, which the hidden layers have 40 layers and 40 neurons, where the input and output layers have the same neurons as the previous hidden layers. So that is all from me. I will pass to the next presenter to present our system demo.
So for this part system demo, I will present for the coding. So this is our coding for our mini group project. We use Python language and Google Colab as our platform. So we import the models such as import pandas as PD, import numpy as NP, import TensorFlow as TF, and we also use import keras. And after that, from sklearn model selection, import train test split. From sklearn pre-processing, import standard scalar. From sklearn ensemble, import random forest regressor. From keras models, import sequential. From keras layers, import dense. So after that, before we import the dataset, we transfer the file for the dataset, which are class CSV and zoo CSV in the Google Colab by using this code. And after that, we import the dataset zoo CSV as a zoo and X, and this is the data in the dataset. And we also import class CSV as class zoo and Y. So this is the data in the class CSV. And after that, I check the any missing data of original data. So there are no many missing data in this data set. And after that, I normalize the data by using standard scalar. And after that, I found that we have 16 input and 101 data. And after that, we split the data into training and test. So it's like X train, X test, Y train, and Y test. So we trained the model and we got 0.99055705882359294. And after that, we train the S data with S train, and we train a Y train, and we test the S test and Y test. And this the next code for neural network. So before I proceed to the coding for neural network, I fix the bash and epoch. So bash equal to 8 and epoch equal to 200. So for me, I will use optimizer Adam, but with the three different activation function, which are relu, cmod, and elu. And I also use 10 hidden layer in this coding. And my friends will use different optimizer, which are Adamax, FTRL, and other grade. With activation function relu, cmod, and elu. But with and also with hidden layer, which are 20 layer, 30 layer, and 40 layer. So here, this the first code for an neural network. Eh, sorry, neural network. We use activation relu and optimizer Adam, and the hidden layer equal to 10. After that, this is the summary, and we train the model, and we got test accuracy equal to 1.0, which are 100%, and test loss equal to 0.01859484988 for 54707718 with a 0 second. So next, I use a different activation function which is Sigmod with same hidden layer and same optimizer. So this is the coding and the summary. And I trained the model and we got test accuracy also equal to 1. But somehow last night I ran this coding, we got uh, not in 1.0, but I from my memory, from my what I remember, we got in about 0.85, maybe 85. I don't know the detail of the exact data, but 85 something like that. And from here we got test loss 0.222735121846199904. And next, for different activation function, which is LU with same optimizer and same hidden layer. So this is the code and this is the summary. And after that, I train the model, and we got test accuracy 0.1124999970197676, and we got test loss 2.29755807647705. So after that, we find the prediction for activation and loop. So this the output, and for prediction for activation ReLU. And after that, I code for the graph. We so this the for the code for model accuracy, and this the output. And after that, this the output, the graph for model loss, and this the graph output graph. So from the graph, uh, we found that ReLU is mostly accurate. Yes, and from the test accuracy also, ReLU is the most accurate. Yes, but for the Teslas, ReLU was the second last, and for the Teslas, uh, so for the modelers, Sigma is the highest loss. And my friends, other three friends have make the change the optimizer and layer, so they already got so the graph and the output for test accuracy in the report. So that's all for the system demo. Thank you.
For our experiment, we will use four types of optimizer, which is ADAM, ADAMAX, FTRL, and ADGRADE. In this project, we perform a total of 12 experiments to test the accuracy by changing between optimizer and activation function. We set our batch size equal to A and epoch equal to 200. In this table, it shows the accuracy result of our 12 experiments, and as we can see here, the highest accuracy result is 100%, which belongs to ADAM and ADAMAX with ReLU activation function. For ADAM algorithm based on model accuracy graph, the highest result is ReLU with 100% accuracy. And based on the model loss graph, ReLU has the lowest loss during training process and Sigmoid has the highest loss. For ADAMAX algorithm based on model accuracy graph, the highest result is ReLU with 100% accuracy. And based on the model loss graph, ReLU has the lowest loss during the training process and Sigmoid has the highest loss.
For the FTRL algorithm, based on model accuracy graph, the highest result is ReLU with 83.75% accuracy, and based on model loss graph, ReLU has the second lowest loss during training process, and Sigmoid has the highest loss. And lastly, for the aggregate algorithm, based on model accuracy graph, the highest result is ReLU with 82.50% accuracy, and based on the model loss graph, ReLU has the lowest loss during training process, and Sigmoid has the highest loss.
Okay, next I will explain about the result that we got from the data training. So the first optimizer that we choose for this data training is Adam, and we train with the three different activation function, which is the first one is ReLU, and we got the result is 1.0, which is 100% accurate. Next, for sigma activation function, the result of test accuracy that we got is 98.75%. Lastly, for LU activation function, the result of test accuracy that we got is 23.75%. The second optimizer that we use is Adamite. So this is the result for LU. We got 1.0, which is 100%. Next, for sigma activation function, the result of test accuracy that we got is 96.25%. Next is LU activation function. The test accuracy result that we got is 25%. The third optimizer that we use is FTRL. So for the first activation function we use is ReLU, and the result of test accuracy is 83.75%. For sigmoid, the result of test accuracy is 40%. Lastly, for FTRL optimizer, we use ALU activation function, and the result of test accuracy is 26.25%. Lastly, the optimizer that we use for this data training is Agagrat. So for the first activation function is ReLU. So the result that we got is 82.5%. Next, for sigmoid activation function, the result of test accuracy we got is 61.25%. Lastly, for ALU activation function, the result of test accuracy that we got is 81.25%.
The strength of our project about zoo animal datasets classification is that first, it helps in classifying animal species without the need of an expert, and second, it saves time because not everyone is familiar with all types of animals, and it will be beneficial for them to know and learn about animals. And the weakness is the dataset has some data that are very similar to each other that could affect the accuracy of our project. By using more precise data to classify the animals, model classification accuracy should increase.
In conclusion, the objectives of this project have been achieved. Value activation function is the most suitable to classify our dataset, as the results shown for all the optimizers has the highest accuracy model. That's all from us. Thank you.